Welcome back. Now we're going to start this exercise by looking at the various aspects of the workspace in Grasshopper. Now most of the different operations and parameters can be accessed through these various tabs at the top. So you'll get to understand the groupings of each of these tabs as you learn and become more familiar with Grasshopper, but ostensibly in simple terms, this parameters tab here is sort of looking for external inputs. The maths tab through here is sort of operations on geometry that are mathematically defined. Sets is a tricky one, and you'll be coming into that quite a lot, and that's about how data is managed, because as various geometries and operations are executed in the routine, you might then have to resort and reorder the information. That's where a lot of these different functions come into it. The vector panel is about setting up planes and trajectories for different geometries. Curves are sort of establishing baseline geometries, either making points through curves through points, setting up planes, dividing curves, and so on. And then building from that, constructing surfaces, some of it through points, some of it through rotations, some of it through curves like lofts and so on. Mesh then is operations on those surfaces, and intersect is different surfaces and how you manage sort of reductions, additions, and interactions between surfaces. And transform is rotations and doing different things with geometries, moving them through space. And display is simply the output at the other side in very simple terms. And you can see through here, you can then start adding in other panels that are very specific, that are third-party add-ons, such as the robots, the KUKA PRC, Karumba, which is a finite element analysis modeling. So when they get installed, they just keep racking up along this top surface here. Now, like Rhino, there is a command line, but it's not immediately visible. To sort of prompt for a command, you double click with your left mouse button and it opens up effectively a command window. And in this instance, I can write different commands, what I think the command is called, and it will give me a set of prompts that thinking, what exactly is it that I'm looking for. And that is probably an easier way while you're learning to try and find different commands rather than trying to sort of work your way through all of these different options. Now, getting back to our wall. So our wall is defined by its SetoutRail and trajectory, which we've defined over here in Rhino. Now we're going to go into the parameters tab, and as you can see here, the parameters are unique in the fact that they're shown as the sort of hexagonal icon. So if we go to the prompt here and type in curve, we can see here that this one is looking for an external parameter, where these are effects on geometry that we've already created. So what we want to do is we want to input our SetoutRail or our curve as the sort of establishing geometry for our wall. So you can see here, I'm going to pull up the curve there, and it's given us an input parameter there. Now there's a little prompt there, and you can see here it's saying we can hover over it, and it says there's a warning message, and it says here that the parameter curve failed to collect data, and that's because we haven't referenced this parameter to this curve. Now to do that, we just right click on the curve, and we're going down here, and it sort of says set one curve. So we click on that, come over to our Rhino window, click on that, and then we've set that parameter. So you can see the color of this has changed. The little warning window has gone away because now we actually do have an input, so that anything that we do this parameter, curve parameter, is relating to this curve in Rhino. Now, with all of these, there's a sort of a standard naming convention for a lot of these elements, but you can adjust them to make it easier to follow. Now, to do that, what we do is that we right click on it, and you can see here at the top there's the curve elements that it's currently called. But what we're going to do is that we're going to call this the SetoutRail, and then connect into there. So that makes it a bit easier for us to follow and for others to follow. Now that we've got our SetoutRail established, we're going to have to start inputting the actual dimension of the brick. Now, to do that, we're going to introduce some number sliders, and we're going to double click to get our prompt, and we're just going to type in a number 1, and that'll automatically give us a slider. Now, we can keep doing that, or we can just select that, Control C, Control V to copy and paste. But once we start to get the 3 sliders, and the reason I'm setting up 3 sliders is for length, width and depth of the brick, it can start to get a bit confusing. So we need to start, I guess, modifying these sliders so that they're a bit more meaningful. So I'm going to right click, and you can see here I can name this slider, and the first one I'm going to name is brick length. Next slider, right click, brick width. Next one, right click, click at the top there, brick height. Okay. Now, as you can see, the slider is just going 0 to 1, which is not very useful to us. So if we, double click onto the slider itself, we can then start to get into the parameters of that slider. Now, for the brick length, let's we can start to look at things like maybe a standard Roman brick up to a concrete block. So the maximum length we'll set as the concrete block, which is 390 millimeters long, and concrete block width, the maximum would be 190, and the concrete block height, the maximum will be 190. Now these are fairly arbitrary, so but within that we'll be able to set our heights. Okay. Now, what we're going to do is then set our brick size, dimension, and array it a set of set-out points along this line here. Now, to do that, we're going to divide this curve into a set of points that will relate to the length of the brick. Now, we can set the brick length, which for a standard brick is 230, so we can try and slide it, or we can just double click into there and input the values directly. So brick width is 110, and brick height will be 76. Okay. Now, I'm going to now divide this curve into my brick length. If we go into our curve parameter, we can look into this division through here, and we're going to divide. We can either divide the curve into equal length segments, or divide it by distance, or divide it by preset length. Now we can play around with these different ones. Now I'm going to divide it by length, simply because we've got a standard brick length that we're going to use. Now this is I guess a parametric operation through here, and we can access information about it. So if we hover over the middle of it, right click, we can then get help, and it'll explain in very simple terms what the different input parameters are. Sometimes that's helpful, sometimes it's not. You have to remember Grasshopper is a user built platform, so it's not going to have the same, I guess, user friendliness as a lot of other pieces of software, and it just comes with the territory. So there is going to be a deal of frustration. But ostensibly what we have on the left hand side are input parameters, and on the right hand side a set of outputs. Now if we look here, this one here is looking for a curve to divide, and it's looking for a length to divide it in. So what we do is to input, to connect the inputs through here, we then get our parameter that we've set, which is the curve, connected into the curve, and then the length that we want to divide it into, and connect it through there. So now you can see our curve is being divided by the brick length. I'll stop it there, and you can pick it up in the next video.